Okay, so let's go for writing your equivalent fraction with an indicated denominator. So writing an equivalent fraction here with a specific denominator is simply looking for a number in which you will be multiplying that number to your denominator so that you'll come up with that specific denominator. So here we go. So let's start with the first one. Let me change my ink. There you go. So the first one here is we've got the original fraction, which is 2/3, and we wish to write that one into a fraction that contains a denominator, which is 42. So here is the thing. We know that the original denominator is 3 there, and we wanted to come up with 42. So we look for the number in which we will be multiplying that 3 with. In order to do that one, you can just simply have your new denominator divide that by the old denominator, because we wanted to know what number we would multiply the 3 with and come up with 42. So in order to find that one, we just simply do the reverse of that one. So we do division. So we go for 42 divided by 3. For 4 here, divided by 3, you have 1. And 1 times 3 is 3. Subtract that 1. 4 minus 3 is 1. Bring down your 2. And then divide 12 by 3. That will be equal to 4. 4 times 3 is 12. And subtracting those two, that will be equal to 0. Now, meaning you've got 14 in there, you will be multiplying that 3 with 14. And since we are trying to do something on our denominator, we also have to do the same thing on our numerator so that we will not be changing our fraction. And to simply say that, you are also to multiply the same number to your numerator so that the number that we are multiplying them with, that will be equivalent to 1. So any number multiplied by 1, that is still the number. So we're not changing it. So this time we are also multiplying your numerator by 14. And this is similarly as 14 over 14, because when you do multiply fraction, it will be numerator, numerator, denominator, denominator. That's multiplication of fraction. So we have here 2 times 14. That will be equal to 28. Now, this is now your final answer. Equivalent fraction of your 2/3 is simply 28 over 42. Next example, we go for 2/5 and writing that one to an equivalent fraction containing 45 as the denominator. So let's start with it. So we have 2/5. You can actually pause the video if you want to solve this one on your own and then resume the video for your answer. Okay, so we have here 45 on the denominator. So we will be looking for a number to multiply that 5 with, and so with the 2. So this is what we are going to do. Have your 45 inside your division symbol, and then the 5 will be outside. So 45 divided by 5, that is equal to 9. 9 times 5 is 45, and this is equal to 0 once subtracted. Now, meaning 5 will be multiplied by 9. That will result to 45. And since we are not going to change our fraction in here, so we are just simply multiplying the entire fraction by 1, or the 9 over 9 in there. So that means we are to multiply our numerator by 2 as well. So we have 2 times 9 is 18. And this is our equivalent fraction. Now, we wish to write 4 as a fraction that has a denominator of 12, so 4 here, and the final fraction there must contain a 12 as the denominator. Now, If you would insist that that is, I mean, 4 is not a fraction, you are really wrong. Why? Because when you say whole numbers are also rational numbers. Rational numbers, we need to say it can be expressed into a form P over Q or a fraction. This is by simply having your denominator with 1. Notice when you say 4 over 1, that is similarly equal to 4. Okay? Now, looking for a number in which we will be multiplying the 1 with, so that will come up with 12 is simply the 12. So we have there 1 times 12. And of course, we will not be changing this fraction, so we also have to multiply the numerator with 12 in there. So 4 times 12 is 48. So this is how you write your equivalent fraction for that whole number 4. Next one, we go for another example. We have 6 to be written as a fraction that has a denominator, which is 18. So we have 6 here. We wish to come up with a denominator that is 18. Now, always know that whole number is or has a denominator equal to 1. And multiplying this by 18, we will be coming up with a fraction with the denominator equal to 18. So again, we also have to multiply the top with the same number multiplied to the denominator. So we have 18 in there multiplied by your 6, and this is equal to 76. I mean, no, it's 6 times 8, that's 48. 6 times 1, that will be 6 plus 4, that's 10. So it's 108. Sorry on that one. Okay, next. We have here write 15 over 40 in simplest form. When you say simplest form, that is the same as reducing your fraction. Meaning to say we are taking off the common number between them. So what we are really applying here is the concept of the greatest common factor. So we find the greatest common factor between 15 and 40 in there. Remember the greatest factor that we did? I hope you still do. So we have here 15 over 40. We wish to come up with the simplest form in that one. So we apply your GCF that we've learned. So 15 and then 40 in there. So we are to do prime factorization here to come up with the GCF. So for 15, we have the 5 and 3. 5 is prime and 3 is also prime. So factors of this one is 5 and 3. Now, next, we go for 40. 40 here can be broken down into 4 times 10. And notice 4 and 10 is not prime, so we can just branch this out. And also this one. So 4 can be broken down into 2 times 2, wherein your 2 is a prime and the other 2 is also a prime. And for the number 10, this can be broken down into 5 times 2. We have 5 and then 2 as prime as well. So writing this one into a prime number or an exponent with a prime base. So we have here 2. There are 1, 2, 3. There are 3 2's. So we have there 2 to the power of 3. This would simply indicate that we've got 3 2's that we need to multiply, or factors of 3 2's in there. Now, multiplying that with a 5. Now, the concept of the GCF is only for us to check whether one number is common between the numbers in there. Now, common numbers is 5, or common number is 5 only. So this one is 5 and this one is 5. It contains the same exponent, which is 1. So that is our greatest common factor, because 3 cannot do. And so with the 2, because they are not common between those two numbers. So what is only common is the number 5, and the highest exponent or the lowest exponent in there is 1. Take note, when we say GCF, we are taking on the common with the lowest exponent, and that is 5. So we have here We divide this by 5. The other one, we also divide it by 5. So this is equal to 15 divided by 5 is 3. And then 40 divided by 5 is 8. So your simplest form for that is 3/8. Now let's go to the next one. So for 16 over 24, you can actually do this one. You can simplify this one by simply dividing it continuously by the number 2. Or if you don't want to do that one because that will take up your time, then you can just simply go for the greatest common factor. So for the greatest common factor, okay, let me just present the one that I mentioned, dividing this one by 2 continuously until you cannot divide it by 2 anymore. So we have here 16 over 24, so we divide this by 2. Because if you do find this very easy, then you can just use it. Anyway, this is a free country, so you can choose anything. Anyways, 16 divided by 2, we have 8 in here. And 24 divided by 2, that will be 12. So we still have another 2, which is common in between 8 and 12. So we have to take that out. So that is why I've mentioned continuously dividing that one. So we have 8 divided by 2, we have 4. And then 12 divided by 2, we have 6. And then divide this again by 2 because we can just take out the common, which is 2. So 4 divided by 2, that's 2. And 6 divided by 2, that's 3. So notice we cannot take out the common, which is 2 in there. That is a no-no because we have a 3 in here, which is prime. So we don't have a factor for the number 3, which is 2. So that is your final answer. Now, using the GCF, so let's have it here. Using the GCF, everybody, you have here 16. We are to break the numbers into prime numbers. So we have 16 can be broken down into 4 and 4. And the 4 to 2 and 2. So 2 and 2 are prime numbers. So for this 4 again, we can just break that up into 2, 2. So we have actually here 2 to the power of 4. Now for the 24, we have that as 8 times 3. And then 3 is prime and 8 is not. So we have to break that up. We have 4 and 2. 2 is prime, 4 is not. So we have another 2 and then another 2. Sorry. Okay, so writing that one into a prime basis, you have there 2 cubed times 3. So getting the common 3 is out here because it's not common between the two numbers in there. So what is common is only 2. But this time we are taking on the lowest exponent because we are talking about GCF. So we have 3 in here. 2 to the power 3, this is simply equal to 8. So we have here 2 to the power of 3, or this is equal to 8. So dividing each of the number here by 8. So this is now equal to 16 divided by 8 is 2. And then 24 divided by 8 is 3. So we have the final answer as 2/3. So it's quite easy for the GCF. But if you find the upper one as easy, then you can just do that one. Okay? Anyways, let's continue. Now, writing 6 over 42 into simplest form, we can do the GCF here, or you can just divide that one with a common number in there. So we have here GCF for 6 and 42. 6 here has 3 and 2, and they are prime, and they are prime. So we have here 42. We have 6 and 7. Sorry on that. I keep on spacing out here because my daughter is always coming in. Sorry. Okay, so we have 42, and then the factors of those of that number is 6 and 7. So we have 7 is prime, and then the 6 is still composite. So we are to break that up. So we have here 3 and 2. So we have that. So 3 times 2 times 7. On the other side, we have 3 times 2. Now 7 is out because 7 is not in there on number 6. But we have the common numbers as 3 and 2. So we have that as the GCF is 6. So we are going to utilize the 6 in there and divide that to the numerator and the denominator. So that means this is equal to 6 divided by 6, that's 1. 42 divided by 6, that will be equal to 7. So you've got that one as 1, 7. And we go for 8 over 56 as our last example in there. So we have this. Let me erase that. Okay. Finding the GCF for 8 and 56. So we have here 4 and 2. But if you know really right away the greatest common factor of that one, then you can just go ahead. But for the sake of those who did not know to or do not know how to get the GCF, then you can just follow the prime factorization tree. So we have here for 56 that will be equal to uh, 7 times 8. So 7 is prime, 8 is not. So we have 8 here broken down into 4 and 2. 2 is prime, 4 is not. So we have there another 2. Okay, writing this one here with prime base. So we have 2 to the power of 3. Well, this one we've got 2 to the power of 3 times 7. So common is 2. 2 to the power of 3, which is equal to 8. So dividing this one by 8 and the other side or the denominator by 8 as well. So this is equal to 1 over 7. So that is now your simplest form. So I hope you learned something.